Hello guys, I trust you're all doing great. Yes, so today I've seen a lot of videos on this topic, and I feel the need for me to, add something to it. Most of the videos are good, but I just feel like they could be much better. So the topic is the properties of combinatorial coefficients. So the properties the properties the properties the properties the properties of combinatorial coefficients. So and this is very vital. It's the prerequisites before one can learn the binomial theorem. Yes. So trying to adjust the camera now so that everyone can see what I'm writing clearly. So now the first thing here is that number one. So the number one property here we'll be talking about is the fact that n combination n is equal to n combination 0, which in turn is equal to 1. So let's look at this. N combination n equals n combination 0 equals 1. Number 2 is that n combination r is equal to n combination n minus r. And the third property is that n combination r plus n combination r plus 1 is equal to n plus 1 combination r plus 1. So these are the three most important properties that we will be discussing. But to really make sense out of this, it's very important to note that 0 factorial is 1. And also, it's very, very important to note that when we say 5 factorial, we mean 5 times 4 times 3 times 2 times 1. And as a matter of fact, I may decide to write 5 factorial as 5 times 4 factorial. This plays out a lot in our simplification. So when we have something like n factorial, we should be able to write it as n times n minus 1 times n minus 2 factorial, because it is actually infinite. It is infinite, and it goes on and on and on and on. It is infinite. So when we have something like when we are asked to simplify, and like when we have n plus 1 in brackets factorial, we can just drop this as n plus 1 in brackets. We reduce it by 1 times n factorial. Yes, so these ideas are very important. So we are asked to simplify something like this. Simplify n factorial over n plus 2 factorial. Yes, look at this. So, these ideas are very important. So how do we simplify this? To simplify this, we just go, so we go n factorial over n plus 2. So we drop n plus 2, by 1, keeps decreasing by 1. It goes n plus 1. After n plus 1, we should have n factorial. And we need to stop at n factorial because we want a situation whereby the n factorial on top will be able to cancel the n factorial under, so that we can be left with something like n, we can be left with 1 over n plus 2 n plus 1, which becomes our final answer. Yes. So it's just like saying that you want to, it's just like saying that we want to simplify something like 6 factorial over 4 factorial. We can just lower the 6 by 2 steps and go 6 times 5 times 4 factorial over 4 factorial. So that 4 factorial can cancel 4 factorial and be left to 6 times 5, which in turn gives us 30. So this idea are very, very vital here. So I believe we are learning these key ideas. So having said all of this now, so where do we go from here? So don't forget, what we are trying to prove are these important properties of combinatorial coefficients. N combination n combination 0 equals 1. So let's see how that goes. So here now, so let's see. So prove. So the proofs, these are the proofs. Yeah, so the proofs. Number 1, how do we show that n combination n is equal to 1? So we know by definition, we know that n combination r is equal to n factorial over n minus r in bracket factorial, then r factorial. So this is the definition of n combination r. So let me just write it. This is the definition. This is the definition of n combination r. So now n combination n will now mean n factorial over n minus n factorial, then n factorial. And after this, we'll see that there will be a cancelling effect, n factorial over 0 factorial over n factorial. So the n on top cancels the n under. We have 1 over 0 factorial. And we know that 0 factorial is 1, leaving us with 1 over 1, which gives us 1. So with these simple steps, we have been able to show that n combination n is actually equal to 1, right? So let's see the step 2 here. So the step 2 is that we want to show that n combination 0 is also equal to 1. So how do we get to show this? That n combination 0 is equal to 1. Yeah, so we go by the definition again, which is that n combination 0 should be equal to n factorial over n minus 0 factorial, then 0 factorial, which in turn gives us n factorial over n factorial, then 1 times 1. N factorial cancels and we are left with 1 over 1, which ultimately gives us 1. Therefore, we conclude that n combination 0 is also equal to 1. Yes, I believe we are following. So then the second proof, which is the second property, which is that n combination R is equal to n combination n minus R. You may have noticed this, that when you have 6 combination 3 or 6 combination 4, this will also be equal to 6 combination 2. And you'll be wondering that how is this possible? And if you have 10 combination, let's say 3, 10 combination 3 will also be equal to 10 combination 7. So, and you may just try and check it out. So how is this possible? Let's find out, like, how. If you do 6 combination 4, 6 combination 4 gives us 6 factorial over 6 minus 4 factorial, 4 factorial. So this gives 6 factorial over 2 factorial, 4 factorial. And we can just drop the 6 factorial a bit so that we can have 6 times 5 times 4 factorial. We can stop at 4 factorial because we have 4 factorial under to cancel it. So that will be left with 6 times 5 over 2 times 1, which gives us 30 over 2, which is 15. Yes, I wish this video could be shorter than this, but sadly, there are a lot of key ideas that we need to talk about. So which gives 15. And we also say that 6 combination 4 will also be equal to 6 combination 2. So let's check out 6 combination 2. Will it also give us 15? So 6 combination 2 will also be, from the definition, 6 factorial over 6 minus 2 factorial, which then 2 factorial, which later will be equal to 6 factorial, or let's just say, yes, 6 factorial over 4 factorial, 2 factorial, which later gives 6 factorial, 6 times 5 times 4 factorial over 4 factorial times 2 factorial. The 4 factorials cancel out. 6 times 5 over 2 times 1 again. And this is 30. This is giving 30 over 2, which is 15. Again. So we see that this checks 6 combination 2 is also equal to 6 combination 4. And I would like you to check out 10 combination 3 with 10 combination 7. So now, how do we now prove using those letters? So using the letterings, let's find out. So using the letterings, because it's when we begin to use the letters that it becomes a little bit clumsy. So n combination R equals n combination n minus R. So we want to prove this. So we are starting with the left hand side. So from the left hand side we have n combination R, and from the definition we know that this is n factorial over n minus R factorial r factorial, and later this will give us n combination n factorial over n bracket open n minus bracket open n minus r. Okay, minus r factorial r factorial. Now let's check, does this add up? No. Here, when you remove the bracket, the n cancel out, leaving us with r alone. There's a problem with that, so I think we should go with n factorial over r factorial. This step is a blunder. R factorial n minus r factorial. Now, so what if we can come up with like n factorial over n minus bracket open n minus r, then we'll put a factorial outside here, then n minus r factorial. Now with this, we know that by the time we remove this bracket, it will mean n minus n plus r, and n minus n will cancel out. So now we see that this, what we have here, will actually mean n combination n minus r. Yes, this is what it will mean. Look at what we have here. This is what it will mean, and you can check from the definition. You'll notice that if we try to simplify this, it will give n factorial over n minus bracket open n minus r, close the bracket, factorial, then n minus r, close bracket, factorial. So this is the proof for the second one. So in the next video, I'm going to be showing the proof of the third one, so that this video will not be too long. Thank you very much.